Okay, this is our very first notes in geometry. Notes number 1 is written on top of the page, points, lines, and planes. Make sure you put your name, the date, and the class period. And then I'll fill in your essential question here in a minute. Here's all this information. You need to listen very, very carefully about this mention because a lot of it's filled in. In geometry world, there are only three undefined terms. There's only 3 of them, and in this whole world there's only 3. And the first one is the point, the second one is a line, third one is a plane. Those are the 3 undefined terms. That means that geometry could not have happened if they just said exactly what they were. That everything else in geometry comes from these 3 concepts, and you just have to take them as they are. But they do say a point has no dimension. Okay, a line has exactly 1 dimension, and a plane has 2 dimension. So we have these 3 ideas of what they're talking about, that a point is just a flat out dot. We just have a dot that is there, and they say it is represented by a capital letter. Let me fill this in. It must be a capital letter for the point. You could also just write the word point A whenever we're having to name the points of a shape or figure. On the line, it is 1 dimension, so that means it has a length. It does not have a width. It just has a length that it is shown. It is represented by a line with 2 arrowheads on the ends of it, but it extends without any end. A writing to name it, I'm going to put it over here by the picture. I have the capital letters A, B, and then this is where it says it's represented by a line with 2 arrows on the ends of it in this fashion. You could also write this, the B, then the A with the arrows over it. Make sure you have arrows on both ends. And then you could also say that this is going to be line. And notice right here in the corner, it looks almost like an E, but that's actually a cursive letter, and it's lowercase letter. That's a cursive L. You can name it by the letter that's on the end. Notice this does not have a point. It's just it's just close to one of the arrows on your line. The A and the B are dots on my line. And then to fill in this little blank here, it says through any 2 points there is exactly 1 line. That is a very, very important theorem that we need to know about. Very crucial, that it doesn't matter what 2 points there are, you can draw a line between them. Alright, on the plane it is 2-dimensional, so that means it has a length and a width. And those are the dimensions of them. It is usually shaped that looks like the floor of the wall. I also say it looks like a parallelogram. But it does extend without any end. In other words, you have to visualize this going on and on and on in all directions. It's like looking at the floor, and it continues on and on and on. Alright, to name this, let me put it over here to the side. You can say that this is a plane. And notice here in the corner there's a capital bold M, and it's in the corner of the plane. And it is a capital, and there's not a dot anywhere near it. So that means this is actually labeled plane M. Or this could be plane, and you'll use 3 letters of points that are inside the plane. So it could be A, B, C, or you can do any combination of this, such as plane B, C, A, plane C, A, B, or any mixture. Typically, we want these to be alphabetical for convenience sake. So this is what we're going to say, is we're going to say these are alphabetical. Alright, to fill in the little theorem here, it says through any 3 points not on the same line, so they're not collinear. In other words, you could draw a triangle if you had the 3 points. There is exactly 1 plane that's going to exist through any 3 points. It makes a smooth surface. Okay, For our example number 1, it wants us just to practice naming the points, the lines, and planes with the correct notation. On letter A, it says give 2 other names for line LN. Well, if I look here, LN is going through the plane. Notice it does not go past the edges, so that means that this line is contained inside of the plane. Notice the plane name is over in the corner, plane Z. So if I want to name this particular line with 2 other names, I can look at it. I'm going to highlight it first. Right there is what I'm identifying. And LN is there. And I can just flip it around and say line NL, but that's kind of cheesy just to say it backwards. But realize I have another point that's on the line. That's an M. So I could do ML. I could also do MN. Need to make my arrows look like arrows there. MN, ML. And then also in the corner, do you see the lowercase b? I could say that this is line B. And notice this B is lowercase. It is not a capital. So I was only asked to ask 2. I have 4 possible answers. There'll be many answers here that you can actually place. Realize I could also push these around. I could do LM and NM, and they would represent the same thing. Okay, on B, it says give another name for the plane Z. Z is in the corner over here, which means this is the entire parallelogram. So to name a plane, remember I need at least 3 points. 3 points names a plane. They have to be in the plane. If I'm looking at my plane, I have L, M, N, and I also have a P that is available. Q is not in the plane because it is above it. I have to visualize this line QS going going through the plane. It's like having a piece of paper and shooting a pin through it. So another name, well, I could say, okay, plane, and I pick any 3 points that are on there. I could say plane L, M, N. Actually, that's on a straight line. I don't want to say L, M, N. Let me do that one. Okay. L, M, P. I just listed the one that you could not name because remember it does say not on the same line right there. And I just named the one that was on the same line, so I couldn't do that. Not. So I could have LMP. I could also have MPN. I could have plane NLP. Any 2 with the P. I have to have the P. Any 2 on the line with the letter P. And any variations of that as well. And what I mean by variations is any order. Alright, on C it says we want to name 3 points that are collinear. Now in your vocabulary, collinear meant that the points were on the same line. You might want to add that on there. Same line is collinear. If I'm looking here, 3 points, straight line, I could say would be L, M, N. If I look at the line A going through it, I have a Q and an M, but I do not have a 3rd point. This is dashed because it's going through the plane. That's what the part you cannot see. So that means I have QM only for the A line, but the B line I have L, M, and N. That has to be my 3 points. L, M, and N. And notice I capitalized them and put a comma between each one. Okay. Then I have 4 points that are coplanar. Remember, coplanar is similar to collinear. Inside here it has the word plane, so that means they have to be in the same plane as all the others. This one was collinear, same line, coplanar, same plane. So if I'm looking at the plane, I have 4 points circled already. Q is outside of the plane, so it is not a coplanar point. It is a non-coplanar. Okay, this one is non-coplanar up here at the top. But whereas L, M, N, and P, they all exist inside the plane, therefore they are my 4 coplanar points. So I need L, M, N, as well as P. Okay, have this all on the first page. Now on your second page at the top, it has 2 more additional vocabularies that you should be familiar with: the segment and the ray. This is all part of a line. It says a line segment AB or segment AB, whichever way you're going to state it, can be written as AB with a little line over it. It does not have arrows. Okay, I'll put it over here in the side bracket. AB with a just a little line over it without arrows. It's said to consist of endpoints A and B. These are the ends of your line, and then all the points that are between A and B. So in this blank comes the word between. So of this line, A and B, the segment is from A to B, everything between it, and that's why there's a line there. With the ray, it's very, very particular. Realize the segment before I change to the ray. This could be segment AB, or you could flip it around and do BA, but typically we only write it alphabetical because those are the same exact line. With the ray, this one is written as AB, but it has an arrow on one side. Sorry, I just looked at the monitor so it was off the screen. Okay? It consists of the endpoints A and all the points on that segment that lie on the same side of A as the letter B. Okay? Note, it says that the ray AB and the ray BA are called opposite rays. Okay, on the ray, one thing I need to add is that it is direction important, because if you're looking here, it says B is the end point and it heads towards A, so this one would be ray BA because it has to start with the end point. So this would be ray BA, but the second one, it starts at A, would be AB. So it is very important on the direction you write this one, so you know which exactly way it's going. And when you have both of them, they're called opposite ray, because that would be like being part of the line exactly if you have them going in opposite direction. So it's very, very important you see that BA is one ray and AB is another ray going in opposite direction. This could be confusing. I just saw up here on this note that I must have skipped over it, but I wrote it over here on the side. I didn't realize it was there. It says that AB can also be named, and that is it flipped would be BA. Segment BA. Okay, on example 2 it says name segments, rays, and opposite rays. On A it says give another name for segment VX. So to say another segment with VX would be, say it backwards, so that would be XV with just a line over it. On B it says name all rays with endpoints W, and then it wants you to specify which ones are opposite rays. Remember, opposite rays go in opposite direction. So if I look at point W, there's 4: north, south, east, west. So I'm going to do north and south, so that'll be W and Y, and I'm going to put the ray symbol over it. And what goes with WY going down would be WZ. And both of these guys are opposite rays. So I'm going to put that beside them because they're going in opposite directions. And then also I have the other ones that kind of sort of going east and west or right and left. That would be WX as well as WV. Notice these are also opposite rays. Notice all of these rays that I wrote all start with the endpoint of a W. That's very, very important in naming a ray. Also, letter C. It says give another name for YW. Notice this is a segment. Another name would be this thing flipped, which would be WY. Kind of a repeat of A, just different letters. Then we have the question on D. It's asking you, is or are the ray VX and the ray XV the same exact rays? Well, to be the same ray, it must have the same exact endpoint, and it must be extending in the same direction. So if I look at this, just looking at the coding before I ever go to the picture, I notice this has an endpoint of V, and this one has an endpoint of X. Just knowing that information, I know this already starts out as a no. If I look at my picture, V starts at the ray starts at the V and goes to the right. The other ray starts at the X and goes to the left. So they are not even going in the same direction. So to answer this question, say, okay, this is a no, but realize there is an explain. So no, the rays do not have the same endpoints. And do not extend in the same direction. Okay, they're going in opposite directions. On E, we're looking at rays VW and ray VX. They want to know if these are the same ray. And I notice they both have the same endpoints, so I need to look at the picture. VW goes to the right, and VX also goes to the right. So we're going to say that these are the same exact ray, so I'm going to put a yes. And reason, I'm going to say they have the same. I'm going to write on the shaded part here. Have the same endpoints. And extend in the same direction. I'm running out of room, so I'm going to write it right below my problem there. They extend in the same direction. Okay, number 3 is practicing our artistic skills. If you don't have any, it's quite alright. Do your best. But this one wants me to draw 2 planes that intersect at a line, and it's going to kind of look like this picture, but I'm going to draw it more like a plus sign that you're looking straight on, so you can see different variations. So I'm going to first draw this with a pencil, and then I will darken it. So I kind of have a parallelogram, and then I'm going to extend it up as well as down as best as possible in that fashion. And then I'm going to draw a line through the center. Okay, now I'm going to kind of fill it in with my colors so you can see them perhaps a little bit better. Okay, there's the blue plane. Here's going to be my red plane right there. And then I'm going to have my line cutting through it in that particular fashion. And for sketching, I need to identify some parts of it. Realize these lines do not exist, so I'm going to erase them inside. And if you're having trouble seeing it, I'm going to shadow the horizontal plane just a little bit to try to ease your visuals. So I'm going to say this is plane P. P, and this is plane X. I'm going to say this is line A. Those three things must be identified in drawing your pictures. On examples 4 and 5, we have a picture given to us, and we just have to identify different items. They want to know the intersection. Intersection means where two things meet. And here they have a line and a plane. On 5, they have two planes. So a very, very important concept is to know that a line and a plane will intersect exactly one spot. Or actually, I'm sorry, I said a line and a plane. This is a line and a line, just two different ways of showing it. Line MX is right here, so that means line MX is in the plane C. It's in that shaded parallelogram, excuse me. And then it has line A. Line A is actually the intersection of the two planes right there. These two lines intersect at exactly one point, and that point happens to be the point M. I just put a capital letter there. If you want, you can put point in front of it. On number 5, it wants to know the intersection of plane C and D. C is my shaded plane, D is my horizontally kind of three-dimensional plane. And two planes will intersect at exactly one line, and it's the line that is in both planes, which happens to be line, and here make sure you use the lowercase a. Okay, make sure you answer your essential question, which I think I forgot to write it up at the top, so I'll write it right here and say, how do you name geometric figures? So in this blank down here at the bottom, geometric figures, there we go. Your essential question is to describe how you name points, lines, and planes. Alright, get that answered. Show it to me and I'll give you your assignment.